on the equatorial line due to a dipole. So now we will derive this. The first thing what you have to consider, you have to take one dipole separated by a distance 2a. Let O be the center. Consider a point P at a distance R from the center of the dipole lying in the equatorial plane. The equatorial plane is nothing but here, this plane only. If you consider it as a plane, then this is the equatorial plane. Or equatorial axis also you can say. That's not a big deal. If you don't want to talk about plane, you can just write that is two-dimensional. Here you are talking about a single line. You can use that also. Now, where we have considered the point P here, which is at a distance or from the center of the dipole. So now, in order to find the electric field intensity at point P, what you will do first thing, you will place one unique positive charge at that point P, correct? So now, according to Coulomb's force, you know that what will happen, this is negative and this is positive. So there will be a force of attraction, correct? So since we are talking about the point P, this unique positive charge will be attracted towards the negative field. So what is the direction of electric field? If you consider this point as A, then EA will be in this way. Since at P it is positive, here B it is positive, it will experience a repulsive force and the repulsive electric field will be in this way. It is EB. Here, any doubt? But here we don't know the distance of these two things, right? How will you find the distance? Use Pythagoras theorem. This is a right angle triangle. So this distance is A. So this one is perpendicular distance is R. So what is that? Hypotenuse will be given by square root of R square plus A square. Here also square root of R square plus A square. So now it will be easy for you to consider. What is the electric field? The electric field at P due to the positive charge. First you take negative charge. Due to the charge, minus Q is given by what, ma'am? Minus Q is given by, is the electric field intensity formula KQ by R square. Here KQ by, what is the distance? Square root of R square plus A square. Better you write here itself E equal to. Since it is a vector, you need to write, or you have to write. Which direction? Along E. Here. The next step is the electric field at P due to the charge plus Q is EB will be equal to again KQ, same charge, same magnitude, not same charge, charges of equal magnitude, so divided by R square plus A square. The only difference is what? Here the only difference is the direction. It is a repulsive force, so along BP, from B to P it moves, repulsive, produced. We are extending the line, right? So BP. Is it clear? So we notice that EA equal to EB, but with the different directions. See, using the formula you can solve, but the quickest way is, okay, how to solve this? I will just draw this diagram here alone. See, this part alone, the point P alone, I will draw it here. So consider the point P. Here, this vector, that is BP, right? Electric field due to B is acting this way, and electric field due to A is acting this way. Right? So here we can just, so this, let us consider this makes an angle theta with the horizontal axis. Okay, theta I have drawn it wrong. Let us consider both the, since they are equal in magnitude, I am taking that. You know that when the forces or the electric field are equal in magnitude, it bisects, right? The resultant vector will bisect these two vectors. So lie in the midway between these two vectors. So let me consider that the angle made by the EB with the horizontal line or the resultant line will be nothing but what? Here theta. I hope you remember that when two vectors of equal magnitude, what is the resultant vector now? Where will be the resultant vector direction? It lies in the midway, right? Making an angle theta means here also it will make an angle theta. The same thing I am using it here. I hope you remember. No. So now it is theta and here also it is theta. Now you know resolution of vector. What is resolution? How will you resolve a vector? If it is along the x-axis and y-axis, no issues. You can directly solve the vector. But when the vector makes an angle theta with the x-axis or y-axis, how will you resolve that vector? Consider this vector A, which makes an angle with the x-axis. How will you resolve this vector, ma? Do you remember? What you can do that? This is nothing but the adjacent side. What you can write? It is A cos theta. And the vertical side opposite, what you can write? It is A sin theta, perpendicular side. Right? A vector can be resolved into two components. One is adjacent, that is A cos, parallel component, which is along A cos theta, the neighboring side of the angle theta. The other side, which is perpendicular to the theta, will be nothing but what? A sin theta. Is that clear or no?
Yes, ma'am.
Kavya, I am not able to see you.
Ma'am, I'm here.
Okay, good. Resolve a vector into two components when it makes an angle theta with x or y axis. If it is along x or y axis, immediately you can solve it. But when it makes an angle with x or y axis, that time you need to use this kind of formula. Is it clear or no? What happened? It is not working. So you can write EB cos theta, and this is the perpendicular side. So this is EB sin theta. You can write, right? So what you are going to write? This one is nothing but EB sin theta. This one is EB cos theta. Clear or no?
Yes, ma'am.
The same way, now this one, here it makes an angle theta with this horizontal line, right? EA. Now how will you resolve this? This one is adjacent, so here EA cos theta, and this side will be, it is EB or EA sin theta. Right? So I am going to draw it here in this side. So this is EA sin theta, and this one will be along here only. So in the same way, it is EA cos theta. Any doubt here? We know that EA equal to EB. So EA sin theta must be equal to EB sin theta, and they are opposite in a direction. So they cancel out each other. Here, this one, the two vectors opposite to each other, same magnitude. What is the resultant? It is 0, right? Pi Newton, pi Newton. What is the net force acting on it? 0. Two equal and opposite cancels out each other. So that's why it is 0. They cancel out each other. So what is left out, ma? The left out is EA cos theta and EB cos theta. Both lie along the same line. or the angle between them is what? 0. So they add up, right? Hence, net resultant force, so that is net electric field at the point P is given by what? EA cos theta plus EB cos theta. Since EA equal to EB, we can write 2EA cos theta. Any doubt, you can stop me.
EA cos theta is equal to?
What the?
What did you say last? EA cos theta?
The EA cos theta plus EB cos theta, right? The EA equal to EB. When EA equal to EB, then what we can take, either one of them we can take it as this thing, right? Or you can simply, if you don't get this point, just let me close and open once again. 2E cos theta, right? Now is it clear, Kavya?
Ma'am.
Yes, Jalak, I will. And when I solved EA, that time also I got E. Two equal and opposite vectors. What is this?
Your voice is breaking up.
Yeah, Jalak. Now tell me. Better. So here E will be equal to nothing but what? KQ by square root of, already we have calculated it, right? Here. So already let it be here itself, you just give it as E and E. It will be B. So now what happens? So the net electric field along the dipole axis, the net electric field at a point P along the equatorial line is given by what? It is given by 2E cos theta. What is cos theta? From the diagram, tell me cos theta. See, this is now the resultant vector. So where EE cos theta and EB cos theta are there. Okay, and it makes an angle. And these two lines are parallel to each other. Listen, this line, okay, and this line are parallel to each other. And then what is this angle, ma? This angle will also be equal to theta. When this angle is theta, this angle will also be equal to theta. So what is cos theta from this? Cos theta will be equal to adjacent by hypotenuse, right? So what is adjacent side? OB by hypotenuse is EB. That is nothing but A by square root of R square plus A square. Any doubt? Is that clear?
Yes, ma'am.
Now substitute this value here. So what we have got? 2KQ by square root of R square plus A square. We have got the whole square multiplied by what is cos theta value, ma? Cos theta value is A by square root of R square plus A square. Any doubt, you can tell me now. So K, you keep it separately, Q into 2A. Just rearrange and write. And here this is square plus 1 by 2. Right? Square root. So how much it will be? It is square root of R square plus A square, or you can write it in this way. The power, if you want to write, R square plus A square to the power 3 by 2. When you take it out of the square root, it will become R square plus A square to the power 1. Here to the power 1 by 2. When you add it, you will get 3 by 2. Is it clear? Now what is Q into 2A? We know that equal to Q into 2A, right? The dipole moment is given by this way. So what you can write? You can write instead of Q into 2A, you can write Kp by R square plus A square to the power 3 by 2. It is nothing but electric field along the equatorial axis. Clear or no this derivation?
Yes, ma'am.
Here if you want to write it in vector, you have to write the unit vector, the momentum vector, okay, which gives the direction of electric. But what is the direction of electric field vector with respect to the dipole moment? Look at the diagram and tell me. The electric field is this way, right? And the dipole moment is this way. So what is the angle between them, or what is the direction? Any one of you tell me.
Ma'am, angle between them will be 180.
180. So they are anti-parallel, right? So here, vector E and a dipole moment are anti-parallel or opposite in direction. And what we can say further? The angle between them is 180 degree. So what you should do here, you should add one minus symbol. The negative sign indicates what? In this equation, the negative sign indicates that the direction of electric field intensity is opposite to that of dipole moment. So once again, let me explain the entire thing. Listen, this derivation is important. As I said earlier, almost 3 to 4 times they have asked in the previous board. Okay.